Imagine having a super intelligent beast at your command. It can reason, it can use tools, it can solve problems. But without control, it is just raw intelligence. That's why every production AI agent is built around one thing: the loop. What is agent loop? User gives input. Input helps in building a context. This context is then sent to the LLM model. LLM model thinks how it needs to solve a problem, whether it needs to make a tool call or not. If it needs to make a tool call, then in this loop, a tool call is made. After the tool call is over, this loop observes the results. The tool results are appended into the context. And again, a call is made to the LLM. Now LLM may say whether I need to make a further tool call or not. If it is further needs to make a tool call, then the loop will continue until the LLM says, I don't want to make any tool call. That is where this loop ends. LLM is the only decision maker. Every LLM agent, every single one, is the same loop underneath. The model thinks, it may call the tools, it observes the results, it thinks again, it stops. That's it. The hard part was never the loop. It's everything wrapping the loop. Memory, approval gates, spend capping, structured output, crash recovery. Today, I'll show you these 8 controlling parameters of the create agent function that turns a raw model into a governed production agent. Now let's run one example where this loop has been created. Watch the loop actual turn. Step 1, the model node. The LLM decides it needs to make a tool call. Step 2, it's a tool node which ran that tool. Step 3, again a tool call has been made because the weather was asked for 2 cities. Step 4, the model node said, I don't want to make any further tool call. It just returned a message. That is where the loop ends. Now, let us go through the 8 parameters. The first knob is model. You can hand it a live chat model instance or a plain string like GitHub Copilot :GPT-4o. See the output. The manifest just set the string. The agent's provider factory resolved into a real chat OpenAI pointed at Copilot's base URL, because here we are using GitHub Copilot and GitHub Copilot is a model provider for us. The second parameter is tool. Tool is the callables that agents can use. The subtle part is what happens when tool is empty. When we have a tool, the graph has a tool node. With no tool, look, there is no tool node. It is just start, model, and end. So you get a model only graph, a single shot LLM call, no hop, no loop, same function, 2 completely different shapes, depending entirely whether you passed tools. The third parameter is system prompt. System prompt is simple, but people get it wrong. It's not sent once. It's prepended as a system message on every LLM call. The output proves it. We intercepted the messages the model actually received. A system message, human message, with our exact prompt text at the front. Every turn, the agent is regrounded in who it is. Parameter 4 is middleware. This is a very important parameter for creating an agent. Middleware is the sequence of hooks that wrap the loop with before model call, after model call phases. Look at the injected node. Model call, limit middleware, before call, after call, summarization middleware, before model, human in the loop middleware, after model. Each one is a governance concern that used to be handwritten boilerplates. It contains spend caps, context compression, approval gates. Agent's middleware factory takes a declarative config and produces this exact ordered stack. Parameter 5 is response format. This is the optional structured output. Hand it a Pydantic schema. Here, weather report with city and temperature in Celsius. And the agent final answers is transformed into this shape instead of free text. The graph compiled cleanly with the schema attached. This is how you make the agent's output safe to feed straight into the downstream code. No regex scrapping the reply. Parameter 6 and 7 are check pointer and store. Both are kinds of memory. 2 parameters, 2 kinds of memory, and everyone confuses them. Check pointer is thread scope. It's the same conversation memory. Watch 2 turns on the thread. Conversation A, and the state remember all 4 messages. Crash the process, reload the thread, and you're exactly where you're left off. Now, store is cross-thread. It's a long-term memory that outlives any single conversation. We wrote favorite city is equal to Paris for user U1, and a brand new conversation, conversation B, could read the same fact. So check pointer is what we have said in this chat. Store is what I know about this user forever. Parameter 8 is human in the loop. It's the last knob and the safety one, interrupt before and interrupt after. These names the node when the agent should pause. That's human in the loop. Output shows it after first call. Paused? True. The graph froze before running a sensitive tool. A human sends an approval. The graph resumes with the command resume and finishes. Final, finished. Crucially, because the pause lives in the checkpointer, not in memory, the worker can die while paused. Another worker picks it up. The approval survives a crash. You express this declaratively via human in the loop middleware. But these two parameters are the raw mechanism underneath. So here's the complete picture. One function, 8 knobs. Model is the one who thinks. Tools, what it can do. System prompt, who it is, every time. Middleware, the governance wrapping the loop. Response format is the shape of the answer. Check pointer, this conversation memory plus crash recovery. Store, forever memory across conversations. Interrupt before and after, where a human steps in. So in this video, we learned about the loops. The takeaway, don't handwrite agent plumbing. The loop is solved. The 8 parameters are the contract. I hope you like the videos. Thanks for watching it.